All right, pre-cal, in this video, we're going to look at an application problem for parametric equations. I'm going to talk kind of fast, so you may have to pause this and re-listen to some stuff. Okay, so suppose that Kyle hit a golf ball with an initial velocity of 150 feet per second at an angle of 30 degrees to the horizontal. Find parametric equations that describe the position of the ball as a function of time. So we are going to write this equation in context of the problem and this equation in context of the problem. So x is going to equal the initial velocity, which is going to be 150, times the cosine of theta, which is 30 degrees t, because I'm writing them as functions of time. Y is going to be equal to negative 1/2 g, well we know g, it's 32 all the time, times t squared plus initial velocity times the sine of 30 degrees t. And since the golf ball is being struck from the ground, there's no indication that it's on a tee, so that means 0, ground 0, so the initial height is nothing. All right, the only thing I would do is tidy this up. Negative 1/2 times 32 would give me negative 16t squared, and that is the answer for part A. All we needed was the parametric equations. Okay, B, how long was the golf ball in the air? Okay, well keep in mind, let's think about this. If I've got the XY coordinate plane and this right here is where Kyle hits the golf ball and it does this, right? Okay, so this is Y, this is X. X is the distance it goes, okay? And the height of the golf ball is this right here. So this is the height. This is the distance, and of course time is passing as this ball is in the air. So we want to know how much time passes before the ball gets right here when y is at 0 again. All right, so I'm looking for y, or I'm looking for t when y is 0. So this is the equation I'm going to use. And I'm looking for t, okay, how long? I'm looking for t. So I'm going to use this formula, or this equation that I found in part A, if I could write. Okay, and now it's going to have to be when y is at 0, just like I said. So that's 0. Here I'm going to factor out a t so that I can solve this properly. And now what do we do with an equation that is written in factors? We set each of those factors equal to 0. So I've got this factor and this factor. So t equals 0 and, 0 equals negative 16t plus 150 sine 30 degrees. So I'm going to solve this equation for t. So I'm going to add 16t to both sides. And then I am going to divide by 16. We're going to need our calculator for this. So I'm going to go to Desmos. So I've got, see, I already did it because I was making sure it was working. So I've got 150 times the sine of 30, which is 75, and I'm dividing that by 16, which gives me approximately 4.6875. So I'm going to go back over here. So the ball is in the air for approximately 4.6875 seconds. So that is the answer to part B. Now part C, when was the ball at its maximum height? Determine the maximum height of the ball. All right, so what I want, let me change colors here. I want to know what y is right up here, right? That is it's at its maximum height. So I need a way to find that. So when did that happen? Well, I know right here that t is 4.6875. So it's somewhere below that, right? Because right here, t has a value, x has a value, y has a value. So when did that occur? Well, we're going to use a formula, a new formula, negative b over 2a. This is the formula for finding the vertex, okay, that or to find t at the vertex, because that is the vertex of my parabola, essentially. Okay, so what does this look like? Well, a and b are your values in your initial equation, because we know that ax squared plus bx plus c is the basic form of a parabola. So that means that a is negative 16 and b is 150 sine 30. Okay, so b, this is going to be a negative b because of this right here. So I've got negative 150 sine of 30 degrees over 2 times 16. And actually it's negative 16, so focus up. Okay, so again, we're going to do that in the calculator. I'm not going to show you how to do that because that's just plugging in or pushing buttons. So at that many seconds, that's when the ball reaches its maximum height. Now we are determining the maximum height of the ball. So we're finding y when t is equal to this. So I'm just going to use some substitution here. Negative 16 times t squared plus that 150 times the sine of 30 degrees times t. And then of course you can just do this in your calculator as well, and that's going to be approximately 87.89 feet. Okay, that's that answer. Okay, part D, determine the distance that the ball traveled. Okay, so now I want to know this value, right, along the x-axis. So now I want to find what x is when t is at 4.6875. I know how long the ball was in the air, but what distance did it cover during that time? So I'm going to use my x equation now, this one right here. So 150 times the cosine of 30 degrees. And what is t? Well, it was in the air this long, so 4.6875. And then again, we'll type that in the calculator. We get approximately 608.92 feet. Awesome. And I can't show you the calculator here, and Desmos doesn't do parametrics the way I like, so we're not going to do this part.